Hello, my name is Hoai-Duy. I come from AI department, China National University. Today, I am going to present my paper, Attention-Based Image and Text Fusion for Deep Multimodal Classification in Disaster Analysis. My presentation includes 5 sessions. First is the introduction session. Second is the related works. Next, I will present about my proposal, followed by experiment result, and final is the conclusion session. So first, I want to introduce about multimodal data and multimodal deep learning, especially in classification tasks. So classification is one of the most fundamental and important tasks in machine learning. Over the past decade, image and text classification has achieved great improvement. In the recent years, in the social media and e-commerce era, digital content is increasingly appearing more and more in multimodal form. And as a result, multimodal machine learning, especially multimodal machine learning, have become increasingly popular in the research community. And the digital content can come from different modalities, such as visual modality in form of images, or language modality in form of text, or speech like voice, sounds, or music, and so on. In my paper, I mainly focus on visual and textual modality. From my study, there are 4 areas in multimodal. There is an area of behavior, computational, interaction, and right now is the deep learning area. So here is the motivation of our paper. In the paper, we mainly focus on the visual and textual modality because the digital data are primarily available in form of image and text peers on social media like Facebook or Twitter posts. And the fact that focusing on either image only or text only can easily lead to misunderstanding of the data. We can see that in the example on the current slide. If we use only the image as the input data, the computer can be easily to conclude that it is a file. But if we combine with the sentence below the image, the computer can know that this is a TV show. Moreover, on the internet, there are a lot of fake news, spam news, and advertising message. And this type of news can contain a lot of noise and irrelevant information. So, without the combination of image and text data, the model performance can be easily hurt, and removing the noise information is needed to improve the model performance. So in our paper, we propose to use an early fusion for fusing the information from visual and textual modality to prevent the misinterpretation. Second, we propose to use the attention mechanism to block the irrelevant information in each modality before fusing layer. Next is the related works on multimodal classification in recent years. This study proposed deep learning methods along with fusion techniques to combine features from image and text for classification tasks. The first paper investigated the early and late fusion. The second paper proposed to learn a joint representation from both image and text modality. And the third paper presents a cross attention to filter the unrelated information before fusing layer. So here is our proposal method. We build out multimodal network mainly based on the self-attention mechanism. As shown in the figure, Our model receives an image and sentence pair as the input data. First, we feed the image into the ResNet. We train on ImageNet to extract visual feature. The sentence is extract the embedded feature by both model at the same time. Next, we use self-attention mechanism to learn the intermodality information for each visual and text feature. Then we use a concatenate layer to fill the feature from visual and textual modality. Finally, the feedforward layer and a softmax layer are added to perform classification. We propose an attention-based fusion technique for integrating features from image and text modality. We use two self-attention modules, one for image modality and the other one for text modality. The different modalities vary in informative information and noise. In the case of non-informative and or even misleading information contained in the modality, the model performance can be reduced if this information is persisted to the last layer of the network. By using self-attention mechanism, intermodality attention can be extracted during the training process. The useful feature will be retained to fit into deeper layer. In contrast, the noise or useless information will be removed. For experiment, we use the dataset named Crescent MMDs. This is a multimodal Crescent dataset. This dataset contains the image and text of tweets on the Twitter during 7 natural disaster events, including earthquake, flood, hurricane, and wildfire. The detail of training, validation, and test set is shown in the table. Here is the experiment result. We use accuracy, macro F1 score, and weight F1 score as the evaluate metrics. We compare our proposal with the other method on Crescent MMD dataset. We also compare with unimodal method and pairwise model from Crescent MMD algorithm. We reach over 90% accuracy for task 1 and over 89% accuracy for task 2 on the test set. The result proves that our model, by using self-attention mechanism for fusing features from image and visual, outstanding both unimodal and the other multimodal method on Crescent MMD dataset. So in conclusion, in this paper we present an approach for multimodal classification with image and text fusion based on the self-attention mechanism. We first extract the visual and textual features from modern CNN-based and transformer-based. Then we execute the self-attention module to learn important information in each modality. Finally, we fill them into joint representation to perform classification. We obtain significant performance on the information and humanitarian tasks of the Crescent MMD dataset. The result demonstrates our proposal outperform both unimodal methods and the other previous multimodal methods. In the future, we plan to do more experiments with different models, visual and textual extractor to improve the accuracy. We also arrange to try cross-modality and co-attention learning to enhance our fusion method. Here are the references. Thank you for listening. Thank you so much.